So really the purpose of this video is just to work out a whole lot of examples that involve inverse trig functions. However, what I decided to do is create those examples by composing together inverse trig functions and trig functions. So instead of just asking you what is the arcsine of negative 1/2, for example, maybe I ask you for the arcsine of the sine of negative pi over 6. The reason I'm doing it this way is because it accomplishes the same goal, getting practice with the inverse trig functions, but this ends up being a context that you often see inverse trig functions in, so I thought this would be a good way to really understand them. So here's 8 examples. Without further ado, let's get started. The strategy for all of these are going to be more or less the same. What you're going to do is work from the inside out. So for this first one, we're going to start by staring at the sine of negative pi over 6. And that might be a value that you already have memorized off your unit circle. If so, that's great. If not, maybe this little illustration can help you remember. Negative pi over 6 is talking about an angle that's roughly over here, and the x-coordinate at this point is root 3 over 2, and the y-coordinate at this point is negative 1/2. What that negative 1/2 means is that the sine of negative pi over 6 is just equal to negative 1/2. I can use that information to rewrite this problem. It's asking me for the arcsine of this thing, sine of negative pi over 6. Well, since the sine of negative pi over 6 is just equal to negative 1/2, it's really just asking me the question, what is the arcsine of negative 1/2? Okay, this is where we're getting into some new information. When you're asked the arcsine of some value, remember you're being asked for an angle. And specifically, if it's arcsine, you're being asked for the angle that, if you took the sine of that angle, would give you negative 1/2 as the answer. And as we saw in the last video, there's several different answers for which that's true. However, for arcsine, we restrict our answers to those angles in between negative pi over 2 and positive pi over 2. So in terms of my unit circle, I'm kind of thinking about the right half of the unit circle where these angles are measured negative. Okay, so what am I looking for again? I'm looking for an angle, and I want the sine of that angle to be negative 1/2. Well, the sine of the angle is the y-coordinate. Hey, wait a minute, I already had that. The sine of the angle was negative 1/2 right here at negative pi over 6. What that means is the arcsine of negative 1/2 is just equal to negative pi over 6. And you're like, hey, wait a minute, there's a negative pi over 6 here and a negative pi over 6 here. Can't I just cancel out this arcsine and this sine? They're inverse functions of each other, so that would kind of make sense that they just cancel out and my answer would be negative pi over 6. It certainly seemed to work in this example. Well, you got to be a little bit careful, and I think this next example will illustrate why. For this next example, we kind of start out in the same way. We're going to work from the inside out. We want to know the cosine of negative pi over 6. Conveniently enough, that angle of negative pi over 6 is already pictured up here, but now since I want the cosine of that angle, I'm looking for the x-coordinate and not the y-coordinate. The cosine of negative pi over 6 is root 3 over 2, so I can replace these parentheses with root 3 over 2. And now the question is just, what is the arc cosine of root 3 over 2? You're thinking, what angle, when I take the cosine of that angle, gives me root 3 over 2 as the answer? And you're like, oh, this is so easy, it's negative pi over 6. No. Be careful. It's true that when you take the cosine of negative pi over 6, you get root 3 over 2, but you have to be careful. The arc cosine is restricted. Remember, the only answers we allow arc cosine to give are angles in between 0 and pi. Negative pi over 6 is not between 0 and pi. Between 0 and pi, you can kind of think of as the top half of my unit circle. So I'm supposed to find an angle up here in the top half of my unit circle so that the x-coordinate of the terminal point is root 3 over 2. Well, we found one up here, but it wasn't in the top half, but there's another one up here that is in the top half of my unit circle and has an x-coordinate of root 3 over 2. Its y-coordinate is positive 1/2, but that's not relevant because I'm talking about arc cosine. The angle in between 0 and pi, so that when I take the cosine of that angle, I get root 3 over 2 as my answer, is not negative pi over 6. It's not corresponding with this point. It's instead positive pi over 6 corresponding with this point up here. What I'm saying is the arc cosine of root 3 over 2 is positive pi over 6, and unfortunately we can't just cancel out arc cosine and cosine and say that negative pi over 6 is the answer, as we see right here. If you really wanted to, you could probably come up with rules for when you can and when you cannot cancel out a trig function and its inverse trig function. It wouldn't be that hard, but I don't think it'll really benefit you. Rarely do you see these problems where the final answer to the question is just the input on the inside of this composite function. So I wouldn't even worry about it that much. I just go through these step by step. On this third one, we want the arc cosine of the tangent of pi over 4. First question, what is the tangent of pi over 4? Well, how well do you know your unit circle? Pi over 4 is this angle that's kind of on the diagonal here. The x-coordinate is the square root of 2 over 2. The y-coordinate is the square root of 2 over 2. So the tangent is the y-coordinate divided by the x-coordinate, root 2 over 2, divided by root 2 over 2, which is just 1. What I'm saying is that the tangent of pi over 4 is just equal to 1, so I can replace these parentheses with the number 1. Then this question is just asking me what is the arc cosine of 1. See if you can translate this question. This is saying find the angle. Remember, anytime it's inverse trig function, start out with find the angle. Find the angle so that if I took the cosine of that angle, I'd get 1 as my answer. The cosine of an angle is the x-coordinate on my unit circle. So what I'm looking for is a point where the x-coordinate equals 1. That's right here. The x-coordinate equals 1 and the y-coordinate equals 0. But there's a problem. There's lots of different ways to refer to this point. It's an angle of 0. It's an angle of 2 pi. It's an angle of 4 pi. There's lots of coterminal angles that'll leave me at this point. Which one do I want? Well, if I look at my restrictions for arc cosine, answers for arc cosine have to lie between 0 and pi. So 2 pi can't be my answer, nor can 4 pi or 6 pi or negative 2 pi. The only angle that leaves me at that point that's within this interval is an angle of 0. What I'm saying is because the cosine of 0 equals 1 and 0 is between 0 and pi, the arc cosine of 1 is just equal to 0. This is really hard. It takes a while to get comfortable with. If you're not comfortable with it yet, that's okay. Don't worry about it. Let's just knock out another example. Start from the inside. Sine of 3 pi over 2. Let's see, unit circle, 3 pi over 2. That's talking about down here. Sine, that's always talking about the y-coordinate. Well, this has an x-coordinate of 0 and a y-coordinate of negative 1. So the sine of 3 pi over 2 is equal to negative 1. I can replace this sine of 3 pi over 2 with negative 1. This question becomes, what is the arctangent of negative 1? Now I have to kind of think in reverse. Arctangent, okay, this is asking me for an angle, specifically an angle that is between negative pi over 2 and positive pi over 2. Those are my restrictions on arctangent, as we see up here. So that when I take the tangent of that angle, I get negative 1 as my answer. Well, let's see. Tangent of this angle was positive 1 because it was diagonal. Oh, right, because when I take a number and I divide it by itself, I just get 1 as the answer. And if I want negative 1 as the answer, I have to take a number and divide it by itself, except one of them has to be positive and one of them has to be negative. So what about, I don't know, maybe this point over here? This is an angle of 3 pi over 4, and its x-coordinate is negative root 2 over 2, and its y-coordinate is root 2 over 2. And when you take the y-coordinate and divide it by the x-coordinate, sure enough, you do get negative 1. So that should be my answer? No. No, because that's 3 pi over 4. 3 pi over 4 is not within the bounds that I need. 3 pi over 4, think 3/4 of pi. That's too big. This is just half of pi. 3/4 is bigger than this number. It's outside this range. It's a great wrong answer, but it's still a wrong answer. For both tangent and sine, I'm thinking about the right half of my unit circle. So I'm looking for an angle in here so that when I take the tangent of that angle, I get negative 1 as the answer. Ah, it's this point down here. This point has an x-coordinate of positive root 2 over 2 and a y-coordinate of negative root 2 over 2. And when I take the y and divide it by the x, I get negative 1. And yeah, you can refer to this point as 7 pi over 4, but you don't want to because 7 pi over 4 wouldn't be in our restricted region. We have to refer to this as negative pi over 4. What I'm saying is the arctangent of negative 1 is negative pi over 4. Sometimes these answers are easier to check than they are to come up with. If the arctangent of negative 1 is negative pi over 4, the first thing I should check is make sure negative pi over 4 is in my restricted range. Yeah, negative pi over 4 definitely lies between these two values. That's good. The next thing I should check is, does the tangent of negative pi over 4 equal negative 1? Well, let's see, negative pi over 4 is talking about this point. The tangent is the y divided by the x. This divided by this, sure enough, is negative 1. That checks out. If you have a hard time coming up with these and you're not super confident in your answers, they're easier to check than they are to come up with. Let's do another one. The arctangent of the cosine of negative pi over 2. Negative pi over 2 is referring to this point again. We've seen this a couple of times. We can refer to this point as 3 pi over 2 or negative pi over 2. The cosine of this point is talking about its x-coordinate. Its x-coordinate is just 0. So the cosine of negative pi over 2 is this 0 right here. So I can rewrite this question as, what is the arctangent of 0? Okay, remember, arctangent, right-hand side of the graph. Tangent is the y-coordinate over the x-coordinate. So how can I take the y-coordinate divided by the x-coordinate and get 0 as my answer? Right there. 0 divided by 1 is equal to 0. The arctangent of 0 is equal to 0. This 0, think of as a number, the number 0 divided by 1. This 0, think about as an angle, my measure that leaves me at this point. Let's do another one. Cotangent of pi over 3. Oh man, cotangent, you're killing me. Just go back to definitions. Pi over 3 is talking about this point right here. From your unit circle, maybe you have memorized that this point has an x-coordinate of 1/2 and a y-coordinate of root 3 over 2. I'm not super comfortable with cotangent, but I do know that it's the reciprocal of tangent, and tangent is the y-coordinate over the x-coordinate. Therefore, the cotangent would be the x-coordinate over the y-coordinate. What I'm saying is the cotangent of pi over 3 is just 1/2 divided by the square root of 3 over 2. If I divide these fractions by multiplying by the reciprocal of the denominator, I get 1/2 times 2 over root 3. And if I cancel out those 2's, I get 1 divided by the square root of 3. Finally, if I want to get this in a more recognizable form, I could multiply the top and the bottom by the square root of 3. I could rationalize the denominator to get the square root of 3 over 3 as my answer for the cotangent of pi over 3. So the answer is just root 3 over 3? No, that's inside the parentheses. What's inside these parentheses is root 3 over 3. This question is asking me, what is the arctangent of this value, the square root of 3 divided by 3? Well, again, because arctangent is referring to the right side of my unit circle, all I'm doing is looking for an angle that would leave me over on the right side of my unit circle here, in between negative pi over 2 and positive pi over 2, so that I'd be left at a terminal point where the y-coordinate over the x-coordinate would be the square root of 3 over 3. If you have your tangent unit circle memorized, maybe you remember that the tangent up here is undefined, the tangent down here is 0, the tangent on the diagonal is 1, and then there's these two other points, one at pi over 3 and one at pi over 6. And one of them has a tangent of the square root of 3, and the other one has a tangent of the square root of 3 over 3. And maybe you have a hard time keeping those two straight, but if you remember that the tangent refers to the slope of the line connecting the origin to that point, and you recognize that the line that I'm drawing in green here is less steep than the line that I drew in red, maybe you'd be able to conclude that the tangent of pi over 3 is the square root of 3, and the tangent of pi over 6 is root 3 over 3. Because the tangent of pi over 6 equals root 3 over 3, and pi over 6 is in between negative pi over 2 and positive pi over 2, the arctangent of root 3 over 3 is equal to pi over 6. In my experience, students really struggle with this, and the best antidote that I've found is just to do more and more examples. So if you're picking this up, great. If not, let's just keep plugging through these. This might be a video you have to watch twice, but at least you'll have lots of different examples. Arctangent again, while we're really beating arctangent to death, of the secant of negative pi. Let's work from the inside out. Secant of negative pi. Negative pi is talking about this point here. The x-coordinate over here is negative 1, and the y-coordinate is 0. If I want the secant, which maybe I don't remember really well, but I remember that it's the reciprocal of cosine, and I remember that the cosine is the x value here, then the secant would be the reciprocal of the x value. The secant of negative pi would just be 1 divided by this negative 1. But 1 divided by negative 1 is just negative 1, so I can replace the secant of negative pi with just negative 1. This question is just asking me what is the arctangent of negative 1. I think that that's something we've seen before. Oh yeah, we saw it up here. The arctangent of negative 1 supposedly was negative pi over 4. Why? Because negative pi over 4 leaves me on the right-hand side of my unit circle because it's between negative pi over 2 and positive pi over 2. And when I take the tangent of negative pi over 4, I'm thinking this y-coordinate divided by this x-coordinate, and this y-coordinate divided by this x-coordinate gives me this negative 1. Last one, I think these are about as hard as I can make them. The arcsecant of the cosecant of negative pi over 2. Wow. Okay, negative pi over 2, we're talking about this point down here. This point down here has an x-coordinate of 0 and a y-coordinate of negative 1. What is the cosecant of the angle that leaves me at this point? Well, cosecant is the reciprocal of sine, and sine wants this y-coordinate. So the cosecant of negative pi over 2 would be 1 divided by this y-coordinate negative 1. 1 divided by negative 1, as we just saw a minute ago, is equal to negative 1. The cosecant of negative pi over 2 is just negative 1. So this question is just asking, what is the arcsecant of negative 1? This is a bit of an unfair question because I haven't told you the restrictions for arcsecant. But because secant is just the reciprocal of cosine, the restrictions are the same as what we saw in red here. Technically, it's an open interval, but you don't need to worry about that. The restrictions on cosecant, secant, and tangent are the same as the restrictions on sine, cosine, and tangent because cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So when I'm asked for the arcsecant of negative 1, I'm thinking it's the same restrictions as cosine, and cosine has the restriction where my angle has to be between 0 and pi, leave me up here on the top of my unit circle. So where up here can I find an angle so that the secant of that angle is equal to negative 1? Well, we've kind of already seen that. The secant of negative pi was -1. But there's a problem. Our answer can't be negative pi because it has to be between 0 and positive pi. But it is this point. Another way I can refer to this point is just mapping it in this direction. Because the secant of pi is equal to -1, 1 over this x coordinate, the arcsecant of -1 would be equal to pi. If you were able to follow that, that's really impressive. I can tell you from experience that most students have to watch these 2 or 3 or 4 times. It takes a while, but the good news is anytime you have a trig function nested inside an inverse trig function, the method that you'll use will be the exact same. Start by evaluating the trig function, and it'll always come off your unit circle. That'll give you some answer. Then you have to take the inverse trig function of that answer. And that's the part that's a little bit challenging, but it's easier to check your answers than to come up with your answers. 2 things to be careful of. Make sure that the angle that you get as your answer is within the restricted range. And then just make sure if you took the trig function of that angle, you got back this value. So in this first one, make sure that the sine of negative pi over 6 really does equal -1/2. In the next video, we'll talk about what to do when the inverse trig function is nested inside here and the trig function's on the outside.